Hey scholars, welcome back from spring break. Hope you're doing great. Hope you had a good time relaxing and getting caught up on work or doing whatever it is that you were doing during the break. My apologies in taking so long to get this lecture out to you. My life's been quite busy for the last several weeks, several months, last year. Anyhow, here it is. This is the lecture video for chapter 7 on informal reasoning. So I recommend, of course, as I always do, having the book out in front of you as you're going through the PowerPoint. And of course, you're looking at the PowerPoint. My recommendation is to be looking at the PowerPoint, listening and watching the audio portion of the lecture. I guess you don't have to be watching it, listening to it, and then of course having the book out in front of you. That way you can just fully understand to the best of your ability the content of this chapter on informal reasoning. There's a number of videos, YouTube videos throughout the slides that I highly recommend that you click on and watch them in light of how it's exemplifying that specific concept within the textbook, as I think that's a really good way to help you understand the nature of that topic. Okay, so slide 2. In its most basic definition, understanding of informal reasoning, it's the process of reaching a conclusion through inference. So you infer something, you observe something, and then you make an inference. You make a conclusion about what you think you observed. You're inferring meaning from something that you observed. So slide 3, you might observe a number of things. You have all these pieces of evidence that are leading to a specific outcome. Inductive reasoning, right? Court of law does it this way. But some questions to consider are: what can you observe? What's empirical? Empirical means that which can be observed. So when it comes to making observations, like this is an empirical concept. But then how are the things related? So there's a smoking gun theory. The thing is, whatever you observe, whatever conclusion you make about what you observe, those things need to be logically related. They need to be reasonably related. So the smoking gun theory, right? I hear a gunshot and I see the room that it's coming from. I open the door, I see someone holding a gun, the gun's smoking from having just been shot. It's safe to conclude, it's fair to conclude using inductive reasoning that the person who's holding the gun that's smoking is the person who shot the gun. That's a logical conclusion. It's reasonably related. It's empirical. So that's the whole smoking gun theory unpacked with inductive reasoning. Okay, the authors talk about causal reasoning. Causal reasoning is really big in the news. It's how people, it's one of the things that affects how we make decisions about diets and exercise and making big decisions about life. Because when you hear that one thing causes another thing, it kind of gets our attention. When you hear that in the news, like doing X causes Y, you're like, oh gosh, well, I do X, so is that going to make me turn into Y? Eating a cheeseburger is going to give you heart disease, or doing this is going to cause bad sleep. You hear all these things that are correlated and are oftentimes explained as a causal relationship, but that's not always necessarily the case. So let's unpack causal reasoning a little bit. The cause produces the effect. X causes Y. X is the independent variable, and Y is the dependent variable. So you'll see that on a X and Y axis, slide 5. So you've probably seen this before, or if you remember back to early math in maybe elementary school, middle school, high school, you heard about rise over run. Same kind of thing. But within multiple regression. Multiple regression is a statistical analysis that you would perform. It's Y equals mx plus b. I mean, that's rise over run, but the multiple regression one's a little bit different. But that's what we're looking at. We're looking at how does X interact with Y? Causal relationships. So think about some cause-effect relationships that you may have heard of in the news. So one is like wearing uniforms and bullying. Do those two things, are they causally related? Does wearing uniforms cause bullying? Does wearing uniforms take away the problem of bullying? Or education and income? Does increasing your education cause you to make extra income? The research shows that it does. The research shows that there's a correlation between education and income, but it doesn't work. It doesn't always work the way that we might think it works. So even if we find a relationship between two things, I'll go with the education and income. I will find a relationship between education and income, such that certain increases in education lead to certain increases in income across the board. However, getting high education doesn't guarantee the income, and having high income doesn't mean that you had a lot of education. But those two things are related. But the thing to consider is what else could account for the cause-effect relationship? And there's a host of factors. So when we're talking about causal reason or causal relationships, and we're using causal reasoning to make an argument, to make a decision, you need to account for all kinds of other factors. In terms of the association between education and income, if you were to think about it for a little bit, socioeconomic status, age and where you grew up, and then your parents' education and income, and just there's so many different factors. You know, where you were centrally located to certain types of schools and how those schools are ranked. I mean, there's a lot of factors to consider. Anyhow, be cautious when it comes to causal reasoning. So I mention this because over the years, there's been a lot of confusion about the nature of correlation versus causation. Just because two things are correlated doesn't mean that they're causally related. So several years ago, there was this research that came out that found a correlation between ice cream sales and drowning. There's a correlation between the two, and this was back in the 50s or 60s. I don't remember exactly. The video I'm going to have you watch is going to talk. The lady's going to talk about this in more detail. But anyhow, what they found is that there is a correlation between ice cream sales and drownings. On paper, like the scientific evidence shows that these two things are correlated. So people falsely inferred and concluded that eating ice cream causes drowning. And so there's all kinds of media attention to this, like be careful when you eat ice cream, because scientists are finding that ice cream causes drowning. Well, finally someone figured it out, and it had nothing to do with ice cream. The drownings had nothing to do with ice cream. What you're seeing is what's called a spurious relationship. So that's on slide 9. A spurious relationship is when you find two things that are correlated, like ice cream sales and drownings, but only because of a third variable called a z variable. In this case, the z variable is what? The case of the ice cream sales and drowning. Those two things are correlated, but only because of one other variable. What do you think that is? Hopefully, you think about it. Hopefully, at least one of you gets it. It's weather. So it's summer, right? So it's because it's summer, and it's so obvious. Usually when I talk about this in class, we're kind of like, oh yeah, it's so obvious. That weather is the obvious thing causing that. But nevertheless, for years, people believed that those two things were related, logically related. And so a spurious relationship means that two things are correlated, but they're not logically related, not reasonably related. And the thing about the shoe size, I mean, the picture of the shoes I included in there to illustrate the fact that when it comes to statistical models, when you're looking at statistical models, if you have enough variables in a model, the more variables you add into a statistical model, you're looking at the association between education and income, but you might also put in all kinds of things, all kinds of other variables. The more variables you add to a statistical model increases the likelihood that things are going to be correlated. And just because two things are correlated doesn't mean that they're logically related. So I had a professor who would always joke about that whole concept, and he said there's the research shows that shoe size is correlated with homelessness, or there was one data set that showed shoe size was correlated with homelessness. It was a model that had so many variables, and it just so happens that those two things were in there and they were correlated, but they have no relationship. There's no logical relationship. So be cautious when it comes to causal reasoning. So I highly recommend that you watch this TED Talk with Ionica Smeets. She's awesome. She does such an amazing job of explaining in detail the nature of causality and the difference between correlation and causation. And she talks about spurious relationships. I don't think she uses that term. She doesn't use the term Z variable, but she explains it so well. And she seems like an awesome person. And she's wearing a really cool sweater kind of thing. If you appreciate cat sweaters, hopefully you enjoy that. But watch the TED Talk. And then on your own, I would just encourage you to look at these questions. What are the implications for mixing up causation and correlations in your own personal life and business, if you're the owner of a company or something like that? And then consider the way that you relate to and understand the general and specific impact of understanding the myriad of unique phenomena and the respective causes. So just think about in general all the different things that you experience on a daily basis, and what were the causes of those things, whether it's, eye color, shoe size, or your outcomes and performances in life. When we're thinking about causal relationships, it's a very complex idea. So that's one way of reasoning, is through causation. Another one is by analogy. So reasoning by analogy, very simply stated, it's comparing two things to make an argument. And you probably heard this. You hear this on a daily basis. One thing is like another thing. In literature, in English, they call it, I believe, it's a simile. It's different than a meta. It's kind of like a similes and metaphors. I frequently get it mixed up, but I'm pretty sure a simile is when you have the word like. So life was like a box of chocolates. You never know what you're going to get. That would be a simile, but it's also implicitly it's reasoning by analogy. It's an argument by analogy. So the authors talk about this, and they say, kind of the logic is, whatever surprises await, they will be yummy, right? Life is like a box of chocolates, and with a box of chocolates, you have a sort of chocolates. Every single one that you eat, it's going to taste good, right? Assuming that you like a variety of chocolates. So everything you eat, it's delicious, right? It's such a surprise, and the logic is that's what life is like. But my question is, really? Not really. It'd be more accurate if some of the chocolates made you sick, were poisonous, tasted horrible, were filled with sand, made you experience a variety of negative emotions, etc., etc. Now, I'm not trying to be negative. I'm not like a cynical person, but the analogy doesn't work, because in life, real life involves a lot of ups and downs, right? A box of chocolates, it's all good. But life, it's more like a roller coaster, right? That's a better analogy, is a roller coaster. But the difference is, too, roller coasters are fun, and there's certain parts of life that feel like a roller coaster, and they're definitely not fun. So when it comes to reasoning by analogy, the idea is that you have to compare two things that are logically related. And the authors give you all kinds of examples of how analogical reasoning works. And then they gave you sort of a sort of a litmus test for how to determine if someone makes an argument by analogy. They're reasoning by analogy. Maybe they're trying to persuade you to do something, or you're trying to persuade someone to do something, and your method of argumentation is this, reasoning by analogy. Well, here's why you should do this, and then you make a comparison. You have an anecdote or some sort of an analogy, and you're hoping to persuade or convince that person. Well, it needs to be it needs to share both. The authors talk about superficial and structural features of the two things that you're comparing. So it's most important that whatever the two things that you're comparing, you need to have a detailed comparison between the structural and the superficial. So basically, if things are superficial in terms of the analogy, and the authors talk about, they give a great example of the human eye and the camera. Superficially, like the camera requires a battery to operate, the human eye doesn't, right? That's a superficial example. But then they give a detailed example of the camera, of how it's very similar structurally. So that's sort of the meat of how that works. And sounds like it might be a bit complex. It is a bit complex. But an easier way to understand it is, life is like a river. You never really know what's I think the life is like a river is a really good analogy, because it's filled with all kinds of things, right? It can be fun. It can be relaxing. Things are going to come up. I I guarantee it, showing you a bayou in Louisiana. So that top picture is like a swamp, like a bayou in Louisiana. Several years ago, I went on a kayak tour with me, my wife, and several people. We rode on kayaks in the bayou in Louisiana at night in the summertime, and it looked just like that. But then there were also alligators all over the water, and we got into some trouble. And at one point I had my oar and I got stuck, and I used my oar to try to get out of the sand, freaking out, also hoping no alligators are around. And then my oar snaps in half, and I'm the new guy, and everyone's like, Jonathan. And so it was embarrassing, but then a guy's like, I got a spare oar, and he handed his spare oar. It's like, hey, so someone's helping me out. I feel like that's a pretty good argument by analogy, illustrating the comparison of my life and river, like rivers like roaring rapids, but also rivers maybe like bayous filled with crocodiles and broken oars. So the two things need to be basically really, really similar to make a strong argument. Okay, let's move on to sign reasoning. Sign reasoning is you make an observation, you notice a sign, you notice some sort of a sign, you make an inference based on that sign. The key is to use caution, avoid premature conclusions, avoid being dogmatic. Like if being dogmatic is when you're stating matters of opinion as though they're true. It's kind of related to arrogance, but it's more so you say something that's opinionated, something that's of an opinion, your opinion, but you just state it as though it's fact. You say it as though it's factual. And that's usually basically reaching a conclusion prematurely. So how do you know when to reach a conclusion? Based on signs, if you're using sign reasoning. How do I know if it's raining? If I looked at that first picture on page 14 or slide 14, if I saw that photo, could I say in that moment that was raining? Looks like it, but maybe that's from a photo shoot. Maybe that's from a sprinkler and it's on an umbrella, and everywhere else around it, it's not raining at all. So on that photo, what I'm saying is when it was taken, was it raining? I don't know. I'd have to see what was going on, right? There's not enough signs. There aren't enough signs to make that conclusion. What about this one, slide 15? Sure looks like it, right? You see the roof, like, looks like a bunch of rain went on a roof and now it's going in the gutter. Is there another explanation for what would account for all this water coming down the roof and going into rain gutters other than rain? And basically it's like if you're making observations of signs and you're trying to make a conclusion, the question is there another explanation for this? And then you get another sign, and then ultimately you'll draw a conclusion. That last one, 16, that last slide on 16, or not the last slide, but slide 16. Is it raining in that one? Sure looks like it. Lady's holding an umbrella. Looks like it's raining. It looks like it's raining behind her. Those streets are all wet. It looks like it's raining everywhere around. Is there another observation? And I know it sounds like I'm majoring in the minors, I'm splitting hairs, but I really wanted to get you to think about the complexity of making arguments when you're trying to persuade someone to think the way that you want them to think. Do your homework, right? Is there another explanation? Maybe. I have in my notes here, Subaru advertisement. So several years ago, my sister-in-law had me and my wife and her husband, some other people, we went on this photo shoot for a Subaru advertisement. And the only thing that we did, we were waiting around forever. It was like 3 a.m. And the only thing that I did was I just stood up, and the photos were taken from like 100 feet away. And it was really strange. It said, lean forward, lean back, lean forward, lean back. Anyhow, my point is they spent what felt like a couple of hours getting the streets wet. So for a couple of hours, they were just soaking the streets with water. And then they were going to drive the car on the wet streets and then do the photos. I don't know if they were trying to simulate what it looks like when something's raining, but my point is you never know what you're seeing, right? Is that raining? Probably. But hey, in my own personal experience, I've been on situations where if you were looking at a photo of something, it looks like it's raining, but there in that case, there was another explanation. It was an advertisement, right? That last one with the vans flooding in there, I would say for me at that point, that's enough to make that conclusion. So when it comes to sign reasoning, keep in mind that a lot of people tend to have a biased vision. They have a biased perception. Oftentimes our perceptual accuracy is biased because of certain lenses that we, so to speak, wear in our mind's eye. Oftentimes we have this confirmation bias where I might have one negative interaction with someone and I assume that they're always that way. So I'm always looking for the negative. And if I'm always looking for the negative, then I have that lens. It distorts my view of thinking. The inverse is true too, where if I had a positive experience with someone, I would always have potentially I would always have a positive sort of lens. So the confirmation bias is I'm always looking for the positive. So if I see something that's really superficial and significant, I might say, wow, what a great person. It's like, well, not really, but if I'm biased, I think that people believe what they want to believe. So be cautious when using sign reasoning, because if we are biased, then we ought to be very cautious about how we make inferences based on the things that we observe, specifically signs. So I have a couple of videos here from a body language expert by the name of Tanya Ryman, and fairly short. That first video is an interview with Meghan Markle, and then the last interview is, I think it's a little bit older. It's an interview with her talking about when Anne Murray left the Today Show or something like that. I forget. Um, so here's the thing. A lot of people will listen to this woman named Tanya Ryman. I'm not trying to throw her under the bus or anything, but she's this a nation's body language expert. She's written some books. She's been on all kinds of shows, right? So you just assume that she's the expert. That when she talks about things, when she makes observations of signs, and that, if you think about like a body language expert, they're kind of relying on sign reasoning. They observe signs of facial expression, the body movements, and they draw conclusions. But here's the thing. Tanya Ryman does not have any sort of legitimate credentials. She doesn't have the only education that shows is it says Pace University, which is a college I think on the East Coast, but it doesn't show her education in terms of bachelor's in this from this school, master's in this from this school, PhD in this. So no one really knows what her actual credentials are, other than she has some education at Pace at some college, and she's written some books and she's been on these talk shows. She doesn't have any. She's never published anything in a credible scientific journal, like a peer-reviewed scholarly journal that does body language research. She's never done anything like that. However, everybody believes her, right? She comes on a talk show, she says something, and millions of people are watching, so they're like, oh wow, okay, so that's what that means. So that first video is on royal signs. It's Meghan Markle's getting interviewed, but just watch. It's like a minute and a half long. It's like a minute long, and you'll hear what Tanya Ryman says when she talks about the eyelash flutter. Like Oprah said, what does the eyelash flutter mean? Or like, what does this mean, the eyelash flutter? And then she's like, it means this, right? And what Tanya Ryman is saying is, Meghan Markle means this because the eyelash flutter, that sign. Like what? And the question for me is, well, how do you know? How do you know that's what she means? Keep in mind on that interview, that little interview with Tanya Ryman, she doesn't provide any sort of theoretical or scientific basis for why the eyelash flutter means the thing that she said it means. And that other one, the same kind of thing with Tanya Ryman looking at an interview with Anne Murray, and Matt Lauer is talking to her. So Tanya Ryman is saying is analyzing Anne Murray's behavior and saying, well, look at the way she's crossing her legs towards Matt. She's not making eye contact. She's making eye contact with Al Roker and the other girl, but not Matt. And you see, she with the arm block. She lifted up her arm to block herself from Matt because she didn't like him or something like that. And again, I'm thinking, how would you know that? How would you know that's why she put her arm up? She gave no reasoning. She gave no scientific basis, no theoretical basis. Yet people are watching the show thinking like, oh, that's what that means. So now when I'm out in public or I'm talking to my friends, when someone does this, if I'm sitting next to someone and somehow their arm goes up or somehow they put their hands on their knee, that means they don't like me because that body language expert on the Today Show said so. So that's why sign reasoning, that's one example of why sign reasoning is very, it can be a very tricky thing. By the way, I've watched this video a few times now, and she talks about how in the footage that's shown on that show, she says, look at how Anne is looking at these two people, but not making eye contact with Matt. If you watch the first like 30 seconds, she's looking directly at Matt. They're looking at each other. He has his hand on her shoulder, and she's crying. It's an emotional thing. I don't know their background. I don't know their stories, and I certainly can't read her mind. I don't know what she's thinking. And the way that some body language experts are sort of portraying themselves is like, I can read minds. I see a behavior, I know what it means. But the fact of the matter is, our faces are capable of making thousands upon thousands of unique micro expressions. It's an area of research I'm not too familiar with, but the point is, you want to be cautiously optimistic when you're engaging in sign reasoning. So they have to talk about weighing the signs, right? I'm on slide 19. You're weighing the signs, right? How do I know how to weigh each sign? Not weigh like obviously physically weigh, but how do I weigh each sign in terms of its importance, in terms of its significance? Like, how many signs do I need from whatever it is I'm observing before I make a conclusion? If I saw you with a shopping cart full of building materials, I don't think I would look at you and say, he's probably going to go build a house in his front yard. That's just not enough, right? You need a lot more than that, right? But those certainly look like materials that you might use for that. But if I saw this, if I walked by your front yard and I saw you doing this, I could probably conclude, yeah, I'm pretty sure he's building a house, right? He's got the foundation going, got the slab, and starting to build all the framing and whatnot. So how much do you need? It just depends, right? It depends on the situation, depends on the context, depends on the variables. So I have a wonderfully cheesy joke to help you remember this. Keep in mind, I'm a dad, great dad humor. So how much does the polar bear weigh? I hope some of you already knew that. Enough to break the ice, right? Enough to break the ice. It's called an icebreaker joke. But that's kind of like the rule of thumb. Like how much sign reasoning do you need? How many signs do you need, and how many significant signs do you need before you make a conclusion about whether or not I can trust someone, whether or not I'll make a decision on a certain job, or inferring meaning from just about anything. Okay, let's move on to generalizations. So when it talks about generalization, we're talking about estimates and predictions. By the way, I definitely recommend that you read all the boxes. So they have the authors talk about box 7.1, or box 7.1 is the overworked Hitler analogy. And that's an example of how that illustrates the degree to which so many people do a horrible job of using reasoning by analogy, using an argument by analogy. So it's a controversial topic, but the authors talk about its relevance to the nature of reasoning by analogy. Sorry, I get them all mixed up sometimes. And then, of course, moving on to generalization. Generalization is you make observations, right? There's a variety of ways to do this. There's your universal generalizations where you say all blank are blank. Those are tricky because if you find one single exception, then that universal generalization, where if someone's saying, oh, all of this will do this, all of X turn into Y, well, all it takes is this one single exception, and then it gets rid of that. It's no longer a generalization. Usually those are not very powerful. Okay, then there's contingent. Think of qualifiers with Tolman's model. And then moving on to statistical generalization. So that's what I want to talk about the most, because the statistical generalizations is what so many people read about in their textbooks. As a student, you read about it in your textbooks, you read about it in the news, or you hear it on news reports and podcasts and all that kind of stuff. Research shows, studies show, a sample of 500 people, and then this is what we found. But how does that actually work? Like, what does that look like? Statistical generalization. I want to talk about the logic of that. So let's say we find a certain result of how two things are related. Let's say education and income. I have a sample of 1,000 people. And if it's a good sample of 1,000 people, then it's a diverse, there's an equal distribution of a variety of demographic factors in terms of diversity, age, socioeconomic status, ethnicity, everything, all the factors, age, level of education, I think I said that, but you'd have all these factors, right? And you find this like rich data from this sample of 1,000 people that seems to represent, at least on paper, scientifically speaking, we say that the 1,000 people in that sample represents the United States, or represents whichever population I'm speaking to. If I'm speaking to the U.S. or California, or whatever, if I have 1,000 people and there's an equal distribution of all kinds of factors, stands to reason that represents that population. So if I find certain results from a sample, then what we find in the sample, we can apply that to the population. And that's the concept of generalizability. So if you have a statistical model that has great generalizability, that's strong. That's a strong argument. You can make a strong generalization. Like, hey, we found this in this model. We found it in a sample of 1,000 people. Here's some outcomes that we found, how these things are related, education and income. Ergo, we can now apply that to the population. If we found it in the sample, we'll probably find a similar result if, in theory, we were to sample the entire population. That's just kind of, hopefully that helps you understand it a little bit better. The nature of statistical generalizations. And then they talk about the two types, whole to the part and part to the whole. There's generalizations, let's say, about basketball players, right? Whole to the part. and I'll be specific, male NBA basketball players. Most, like the overwhelming majority of all male NBA basketball players are tall, very tall. Most of them are very tall. You can make that generalization. Nearly all male basketball players are tall, right? That's an easy generalization to the whole, but you can't apply it to the part. In other words, you can't just see a tall person and assume they play basketball. I've known some tall people in my life, right? Whatever, and I've just worked with some different tall guys before, and they tell me how like certain tall guys who never played basketball, they basically said my whole life everyone just assumed I played basketball, and they got mad at me because I didn't play basketball, and they thought there was something wrong with me because I didn't play basketball. So people just assume like, well, you're 6'8", so you must have played basketball. No, why would you think that the whole applies to the part? It doesn't always apply to the part. Part to the whole. The opposite is, let's say you had a couple of negative experiences with a certain thing, a certain person, maybe going on a date with someone, or a professor that you had, or a job that you had, or a certain customer. Um, if you had, you had three negative experiences at a particular restaurant, and then or whatever, and then you just falsely assume that every restaurant or every professor at a certain college is like that. I had three bad professors at this one college, and so all professors at that college are bad. Well, man, if you had three bad professors at a college that has, let's say, 3,000 professors, 2,000 professors, you can't apply that, right? You can't. That's not a unique, or that's not an accurate sample of the population. Um, so oftentimes that relates to that results in a hasty generalization, right? We prematurely reach a conclusion, and we say, oh, I had a couple of bad experiences, so this place must be bad, or these people must be bad, or this school must be bad, or this restaurant must be bad. You can't really conclude that just on a couple of instances, which if you did, it'd be a hasty generalization. As related to the peripheral route of processing information, so some review, right? ELM, elaboration likelihood model. It's a mental shortcut, right? It's easy to make these kinds of conclusions, but it's kind of being cognitively lazy. I mean, it might sound bad, but that's kind of oftentimes what it is. Or you just didn't know. You didn't know. Oftentimes people make hasty generalizations, not really understanding the whole concept. Not people don't always think I've had three negative experiences. Does that mean it applies to everyone? A lot of people skip that step. They just never think to ask the question, probably because they haven't taken a course like this, or critical thinking, or they haven't been exposed to information and knowledge that has taught them how to like separate the different components of things in their social lives. So I have another sort of analogy, and it's that last slide where it says good, bad, and the ugly for informal reasoning. So one way to think about understanding all this informal reasoning, as you read through all these different things in this chapter, you probably thought, I've done that so much, or I know people who do that, or like, oh, I've seen that illustrated in a movie or in a book or something like that. And it's almost like reasoning in this way, when we observe our social phenomena, when we reason this way, it's almost like a game, right? There's so many different ways that we can make sense of the things that we observe. And there's some good ways to do it, and there's some bad ways to do it. And hopefully what you've learned from this chapter is these are teaching you how to do it. These are good ways to do it. These are the proper ways to do it. But just because you apply some of this logic and you apply some of this reasoning to your own lives or how you make decisions, it doesn't mean that it always works out the way you want it to work out. In theory, it should, or at least it should work out better than if you had no strategic approach. If you just did a sort of a Hail Mary, like, and you're trying to make a big decision, I'm just going to flip a coin. Well, flipping a coin is definitely not, doesn't go into to one of these categories. So the good is you understand things better. You understand the nature of reasoning in all aspects. After reading this chapter, studying it, writing about it, reflecting on it now and in the future. So that's the good. The bad is when it doesn't always go your way, right? Or the bad is when sometimes you observe someone committing fallacies, right? That's one of the next chapters, committing fallacies, or they're trying to use a certain kind of reasoning, and you recognize they're not doing it correctly. And the question is, if it's your friend, should I correct the person? Because I know what they're doing right now is they're reasoning by analogy, but those two things are not related. they're not related that well. So do I call them out? Is that going to harm our relationship? Um, maybe, maybe not. You never know, right? That might be the bad, right? You broach these uncomfortable topics with either your friends, family, coworkers, whomever. The ugly could be an example of how something might turn into verbal aggression. Oftentimes, when people are not they're not reasoning properly, they're resorting to fighting or emotional abuse or verbal abuse, and that's the ugly. Um, that's when people don't reason well, right? They're being unreasonable. So that's a good, bad, and the ugly. Now I have this video here called the still face experiment, and I want to explain how I think it's kind of related to what I just said. This is an experiment that deals with the nature of human development, and what you're looking at is a baby, and the doctor is explaining how babies respond to their social environment and how they respond to their primary caregivers, generally mothers, but primary caregiver, and what the guy, Dr. Edward Tronick, he first starts off by saying how historically, it's kind of hard to catch the first word he says, but he says traditionally, historically, a lot of people didn't really think that babies were aware of their social environments. A lot of people just assume, doctors, scientists, all the experts, they just thought, hey, babies are just there. They're just adapting to their environment. They're not really that aware. They're not really that aware of all the things that we grown-ups are aware of. But that was later debunked, right? Of course they are. Yeah, babies are highly, highly, highly engaged with their five senses. They're highly engaged with people. When a newborn baby is born, they can't see very much, right? You have to be like this close to a baby to see them because they were just born. They were in a dark room for 9 months, 10 months, or whatever, 9.5 months. But as they get older, they're very, very aware. They're very engaged with the social environment. And the doctor talks about the good, the bad, and the ugly in terms of human attachment. The good is that consistent attachment, right? The bad is, hey, sometimes mom has to leave, dad has to leave, primary caregiver has to leave, the baby cries, right? Or maybe the baby cries because they have gas. Okay, the baby might cry for a while, and that might be a bad thing, right? But then the baby gets rescued. The baby gets that comfort he or she needs. Um, and then the baby recognizes, okay, it's okay, right? The baby starts to use reasoning. The human starts to use reasoning, informal reasoning. Okay, I get this certain feeling in my stomach. I cry. Sometimes I cry for like a minute, sometimes 5 minutes. But then my mom always comes against me, or my grandma always comes against me. Okay, I'm starting to learn how to reason and realize, okay, this pain I get, this gas or this hunger or thirst, I guess I don't have to cry. At some point, I'm going to learn how to say like wah, or like bathroom or food, right? I'm learning how to use words. Okay, I'm making patterns. Okay, the ugly, the doctor talks about how the ugly is that consistent neglect, right? Detachment, right? The baby's gone for too long, it detaches. And so when it comes to informal reasoning, if you're in an environment where people are always using irrational reasoning, they're making very foolish decisions, they're violating all of these forms of reasoning, it's very difficult to reach um, a sane level of thinking. It's very difficult to engage in proper critical thinking and to make good arguments if you're always surrounded by that, right? By the lack of good reasoning. So throughout life, we are constantly making observations using sign reasoning from babies, right? I see a sign, I hear a noise every time, every day at 5 o'clock. I hear a certain car shut off, and then as babies, as kids, we start. That's dad's car, that's grandma's car. We recognize sights and sounds and smells, and we start to we make patterns, and we learn how to navigate things from. My point is we've been doing this from a very, very young age, and now you're in a argumentation course. Now you're learning how to do it in at the highest level, right? You're now at the highest level of informal reasoning, of making conclusions based on the things that you observe in your social environment. This is the highest level in terms of this is what lawyers have to study. This method of reasoning, what law enforcement has to study. It's been around since Aristotle, Plato, etc. So that's my last part of my way of kind of understanding this as an analogy as it relates to the way we start responding to our social environment from the moment that we're born, from before we're actually born. But anyhow, that's informal reasoning, and I hope you're all doing great. Talk to you later. Bye.